Hello class. When you first try the lab, it seems easy enough, but you rapidly run into a little complication. And let me show you what that complication is. I'm going to put all of the A into this beaker and all of the B into this beaker. You can get as much A and as much B as you want by grabbing additional flasks, just so you know. Now in this beaker, there is only C. You can see there's no A, there's no B, there's only C. C is 0.5 molar. That's the complication. Because after you set aside the 50 milliliters of C that you need, 50 milliliters. I'm going to rename this to be 50 milliliters of C. Done. That's what I need to turn in via screenshot. Now here I have 150 milliliters of 0.5 molar C. So I'm going to add some D to it. But how much D do I add? I can't add this much D, because if I do, I'll have a monster. Let me show you. Suppose I add 100 milliliters of D, and I get 50 more milliliters of D. That's a total of 150 milliliters. 150 milliliters of D. What have I got here now? I've got 300 milliliters. That's expected, but look, I've got D and I've got E. That's not what you want. You want only E. So you have to calculate. You have to do some calculations so that you get just E. E? Yes, E. Alright, so now let's do that again. Get my beaker. So here I've gotten back my 150 milliliters of C, and I'm making E, right? So I'm going to add some D in here. Now how much D do I add? Let's calculate it this time. Let's do it a little more carefully. You get 1 C and 1 D to make 2 E's. Now these numbers, 2 and the unstated 1 and the unstated 1, these are moles or molecules or numbers of things. Whereas what I'm working with in the lab are volumes. So I just need to do some calculation. Let's see. 1C, 1D makes 2E. So I need 1C for every 1D. Alright, so how much D have I got? Well, I've got 1 molar and 100 milliliters. And how much C have I got? 0.5 molar, 150 milliliters. I'll start with that C. I've got 0.5 mole. Molar means moles per liter. That's moles over liters. Like that. Moles, 0.5 moles over 1 liter. And that's moles of C. It's liters of the C solution. Okay. And that times how many milliliters was it? It was 150 milliliters. But you need to convert that to liters. So we can just do it like this. 1 liter of C, 1 liter of C is 1,000 milliliters of C, right? Okay. So, milliliters of C cancel with milliliters of C, liters of C cancel with liters of C, and you end up with moles of C. And so, we have here, calculator, 0.5 times 150 divided by 1,000. 0.075, so that's 0.075 moles of C. That means I need the same amount, 0.075 moles of D. Does that make sense? Just in case it didn't. It's because for every 1 mole of C, I need 1 mole of D. Alright? So now I need to calculate how many milliliters it takes to get 0.075 moles of D. Now, what is the molarity of D? We have 100 milliliters of it. We can get as much of these 100 milliliter flasks as we want, but the molarity is 1 molar. That means it's 1 mole in 1 liter. Okay? So if you need 0.075 moles, if it's 1 mole in 1 liter, then that's the same as 0.075 liters. Let me show you. 1 mole. So this is 1 liter of D is in 1 mole of D. Okay. So, see, moles of D cancel with moles of D, so you end up with 0.075 liters of D. But in this virtual lab, we're speaking in milliliters, so I'll just convert this over to milliliters. You can see what I'm doing, right? If you can stop the video right now, because there's nothing more to this video. It's the liters go on the bottom. So yeah, there are 1,000 milliliters in 1 liter. So okay, so liters of D, liters, and milliliters are all that's left here. So milliliters are all that's left there. So the answer is going to be in milliliters. So I'm going to need 0.075 times 1,000, means 75 milliliters. So watch the pro, ladies and gentlemen. 75 milliliters, bang! And look, this thing is 0.67 molar in E and this much in C. But what is this? This is 0.16 zeros, 0.0000001. In other words, this is negligible. The C is negligible. So this is very nice. So what do? You put it in a clean flask. Let's just assume it's a clean flask. You put 50 milliliters of it. So this. That's not what I wanted. I want a clean flask. Yeah, there's a clean flask. Put 50 milliliters in there. Yeah. Okay. Right click. Rename. We got 50 milliliters of, what is this, E? Yes, of D. Okay. Why is it that this is okay? It seems to be the case that there is some C. There really isn't any significant C, and here's why. That number was 5.551 E minus 17. That means 5.551 times 10 to the power of minus 17. What does that mean? That means 0.12345. 0.0000000. Oops, 551 molar. Okay? What does that mean? That means in 1 liter you have 0.00000005551 moles. That means almost 0. Why does that mean almost 0? Because significant figures. If you add that to your point, how much E do we have in there? E was 0.6667. Okay. If you add it to your 0.6667 molar solution, then what you get is your 0.6667 molar solution. These numbers here, they're after all these zeros, so they take up a very insignificant amount, you know what I mean? Basically, if you end up with any solution that has other components, A, B, C, D, or E, other components than the components you wanted, if those other components are less than E minus 7, then you're fine. You can just keep those in there. In fact, if they're less than even E minus 5, you can keep them in there. Okay? Things that are of major concern to you is if there's something in here other than what you wanted, and its concentration is e minus 4, or e minus 3, or e minus 2, or e minus 1. Those are problems that you need to solve using the math that I have demonstrated.